I want to help you understand what an ellipse is because it's very important in understanding how planets move around their stars, like our Earth moves around our sun. Another word for an ellipse is an oval, and that might be more familiar to you. We're going to do some geometry here. So think about an imaginary point. And when I have an imaginary point exactly in a circle, that point is an equal distance from the circle anywhere I measure it around the circle. It's exactly in the middle. Well, now imagine that I have another imaginary point. And when I have a circle and that second imaginary point is exactly where the first one is, I have a circle. But watch what happens if I move that imaginary point away from the first one. Now I have an ellipse. It stretches it out so it's no longer a circle. This is called focus 1 and this is called focus 2. When the two foci are close together, the ellipse is more like a circle. Remember, it's a perfect circle if they're on top of each other. But when they're stretched a little bit, it's not very eccentric. New word there, eccentric. If I stretch it even more, it becomes more eccentric. When the foci are far apart, the ellipse is more eccentric or eccentric, if that helps you to remember it. Well, what does this have to do with orbits? Remember, when a circle has two foci on top of each other, it has no eccentricity. An orbit that is a circle has two foci on top of each other. In this orbit, both foci are in the middle of the sun or the star for this orbit. We have a perfect circle. But remember that an ellipse has the foci spread apart and is eccentric or eccentric. When I stretch them apart, it becomes more eccentric. An orbit that is an ellipse has two foci spread out from each other. In this orbit, the foci are spread out. One is in the middle of the sun. Remember, these are imaginary points that help us to explain the shape of an ellipse. The other focus is imaginary, and it lets us explain the shape of the ellipse.